I'm Josh Chisholm, and this is going to be my attempt at solving week 10's problem, question number 1. So what I'm going to do is try and explain the difference between the dot and cross products. I'm going to try and explain how to interpret it as a multiplication of a vector and compare the properties of the multiplication between real numbers. So I'll start off with a quick comparison. So drawing up a little table just to show the comparisons between the two. The reason a dot product is called a dot product is quite simply there's a dot between the A and the B vectors, and cross product is literally just a cross. So that's the first obvious visual difference. In terms of measurements, dot products are a scalar, whereas cross products give us a vector measurement. The calculations for a dot product to get your total lengths would be AB cosine theta, with A being this one here and B this one here, to give cosine theta in here. And then with the cross products, that compares to AB sine theta. And same again, that gives us our angle. Obviously sine works slightly differently, where it goes 0, 90 to 180 degrees, and cosine the same way, 0, 90, 180, whereas cosine will start at 1, 0, and then minus 1, whereas a sine will do slightly different, so it goes 0, 1, and 0. So you're going to get slightly different outcomes. Dot products are used to tell us how parallel our vectors are, whereas the cross products are used to tell us how perpendicular our vector lines are. With a dot product, the order of multiplication doesn't matter, whereas with our cross product, it certainly does matter. So that's going to have implications on our outcomes. For instance, with the dot product, if you were to do A dot B, that would look like A squared. Or you could do A dot B, and you could write that as B dot A, and that wouldn't have any implications whatsoever. Sorry, I made a mistake here. That should be A dot A, not A dot B. So A dot A would be A squared. A dot B equals B dot A. It doesn't make any difference what way around that goes. A dot B plus C would be A dot B plus A dot C. If we compare that to the cross product, A cross A would be 0, because that would mean it would be parallel with itself. A cross B equals minus B times A. And negative just means it's reverse. And then if we were to do A times B plus C, like we do with the cosine, we'd have to write that as A cross B plus A cross C. So going back to the cross product and our AB sine theta, that's defined by our right hand rule and be perpendicular to A and B. So that's going to give us n hat, and n hat's going to be a value that either comes out of the page and can be represented like that, or is going to go into the page and represented like that. One analogy I've got of how the dot product can be interpreted as a multiplication of a vector. You could use it to find out the total speed. You would take the speed along the x-axis plus a potential increase in speed along the x-axis times those, and add that with the speed along the y-axis plus that potential increase in speed along the y-axis to give us a total speed. So that would work in a situation where on a video game, if you're on a racing game and there's a boost in front of you, if you hit that boost at the perfect direction using your initial speed, then you can use that dot product to calculate the total speed you'd get from that boost. But the vector obviously controls it. You're going to get a maximum total speed if you hit that boost perfectly straight and in the correct direction, whereas if you hit it sideways, you're not going to get the max boost from it. We use cross products in relation to vectors whenever we hear perpendicular vector. If there's a perpendicular vector, then we can use the cross product and the determinant of the matrix to give us answers to certain equations. For instance, curl, we can use that to the determinant of that matrix to give us the final formula for curl.